Hi everyone, I believe you are doing great. Today we will discuss about RAG, Retrieval-Augmented Generation. For example, we have different documents like .pdf, .docs, .csv. So what we want to make our database like some vector database, and we want to store that all the documents in that database. So after storing, we want to do the question answering. So in today's video, we are going to build the ingestions pipeline. So for example, we have different documents. We'll see that how to make a vector database from these all the different documents. So in maybe next video, we'll see that how to use this database to do the question answering. So without wasting any time, let's get started. Here I just copy paste some important things like here I import operating system, JSON, CSV, time, and different things. And I am saying my data directory is space data. I will share this data with you guys also. It is the space data folder. In this we have Novatech, .docs and space exploration rag document, .docs. For now it has only two documents. So I'm saying what I want to just load, I want to load this file, space exploration rag document.docs. So let's run it. And after that I am saying from langchain.community document loader import doc to text loader. Langchain provides different loaders, like it provides to load .pdf, .csv, .json. We'll see all these loaders in a while. So here in doc to text loader, I pass data directory / our file, this one, and it will load the document in this DOCX docs. So let's run it. So it is saying document loaded 1, it has these characters and metadata, or it is saying source is this one. Let me copy this and paste here. So after loading the document, we want to make the chunks of that documents. There are different techniques to do the chunking. So one important technique is recursive character text splitter. So here we are saying our full text will be docs.page content and its metadata will be stored in metadata, and we are printing total character by printing the length of full text. It basically tries to build chunks close to 500 characters, and whenever it needs to split, it prefers the best separator available in this order. First of all, it will prefer paragraph. So whenever there will be double new lines near 500 character, it will split on the basis of paragraph. So if there is no paragraph, it will prefer new line. So if there is no new line, it will split on the basis of sentence, otherwise word and then character. And here length function is length, means we are telling to the splitter use the length to measure the chunk size. And chunk overlap is 50, means every new chunk will have 50 characters of previous chunk. And here we are creating the chunks, we passing the text and metadata. So let's run it. It is saying we have created total chunk that are 59. Average size of chunk is 354 characters. Minimum chunk is 45 and maximum chunk is 496. Okay, now let me just copy these lines and I will paste here. From LangChain Ollama, I import Ollama embedding, and from LangChain community.vector store, I import FAISS. And for embedding, we are using this MXBI embed large latest embedding model. It is free. You can pull from Ollama. So you type Ollama pull this model name. So let me just run it also. And I will copy paste this thing. We are creating the embedding of this sentence, and it will print the vector length. So it is creating the embeddings. It is saying it created the embeddings, and embeddings length are 1024. Here we are saying for chunk in recursive chunk, want to get chunk dot page content, and for chunk in recursive chunk dot metadata. So let me copy and paste. It will print text length and metadata length that are 5959. And if we want to print metadata, so it is the source basically. Here to store the embeddings and text, we are saying FAISS.from text. We pass text is equal to these text, and metadata will be metadata, and embeddings will be our these Ollama's embeddings. So let's run it. Here it is the question, like when did the space age begin, and expected answer is this October 4, 1957. So let me just copy code and paste here. So our query is when did the space age begin and what event marked it. So we call this vector store.similarity search, and we pass the query, and we want k is equal to 2, means we want the most 2 relevant chunks from our vector database, and we store that chunks in this result, and we print the results by using the loop. So let's run it. So our first chunk is this history of human space exploration, and the space age began on October 4, 1957, and it is the second chunk. After that, let's use some LLM, like from LangChain Ollama import chat Ollama. Our model is QN 2.5, temperature is 0.2. It is our query, and here we are getting the chunks from our vector store, and we store it in context, and it is our prompt. You are helpful assistant, answer using only the context below. Context is context and the question is query. We pass this prompt in our to our LLM. So we pass the query as well as the context. So let's run it. So it returned the answer. The answer is the space age began on October 4, 1957. So basically we pass the context as well as the query or question to the LLM. So on the basis of that, it returned the answer or generate the answer. So next step is visualization. So here I type visualization. We want to visualize our database. So let me just copy and paste the code. Here we are storing another file, Novatech handbook.docs. And now after loading the document, we know that we need to create the chunks and all the different things. I import recursive character text splitter, and chunk size is 500, and it will create the chunks, and here we are debugging. That's it. So it is saying we have total 9 chunks. Average size is this, minimum and maximum characters are these in the chunks. So let me copy and paste. We are storing page content and metadata in text 2 and metadata 2 this way. And to store these text and metadata in our vector store, we call this function vector store.add text. So it is our vector store. Let me show you. It is the vector store. We create the instance FAISS.from text. So now this time we call this text is equal to text, and metadata will be metadatas too. So let me run it. It has added all the documents. So to get the vectors we have stored in our database, we need to run this script. So let me run it. So it is saying that we have 68 chunks basically. Okay, now we need to apply the PCA on this vector. PCA basically reduce this vector, like it reduce the dimension from 1024 to 2. So let me just run it. it reduced the dimension from 1024 to 2. Here we are getting the labels of our two files that we have stored in our vector database on the basis of its metadata. So let me just run it, and let me just copy and paste to show you the visualization. So it is the visualization, it is our first document and it is our second document. After creating the database, we need to run this command to save our database. So maybe later on we will load that database. And guys, let me show you the different loaders of LangChain to load .txt file, .json file and .csv, docs and pdf. So let me just run it. To load .txt file, we import text loader from document loader. So let me run it. And to load .pdf, we import PyPDF loader. And similarly, we know that to load DOCX, we import DOCX2 text loader, this one. And to load CSV, we use this .document loader, .csv loader, import CSV loader. And to load the JSON file, LangChain provides JSON loader, and we have another option for manual loader. So let me just run it. So after loading text doc, PDF doc, docx, CSV docs, JSON docs, we want to combine all in all docs. So let me also run it. So it print a very beautiful table, like these are the sources and formats, documents, total characters and average characters. So in this way you are able to add different documents in your vector database. So for now that's it, and guys, don't forget to like and subscribe, and see you guys in next video.